Okay, Algebra 2 students, in this video today we're going to be studying a process that is called synthetic division. Synthetic division. Now, we will use synthetic division for two situations. Okay, do you understand? Two situations. Your heading today is synthetic division. Lesson 9.4 part 2. We've already looked at long division from lesson 9.4. Be sure to include today's date, okay? Synthetic division, lesson 9.4 part 2. Be sure to include today's date. Now first, understand that we are going to use synthetic division for two things, okay? Here they are. Please copy these down. We are going to use synthetic division in place of long division. Now that cannot always be done, but in some long division problems you can use synthetic division, which is much faster, much easier, okay? And we can also use synthetic division to evaluate functions at a given value. Now I'm going to explain both of these things later, but that's what we're going to use synthetic division for today. Alright, now we're going to be looking at both of these two cases today. Understand that long division, you understand, was an extensive process, right? Think about how long it was, all the work we had to do. Long division can be really a pain. You know what I'm saying? What if I told you that we could replace long division? Are you listening? In some cases, not every case, but what if we could replace long division in some cases with synthetic division? And synthetic division is much easier. Well, we can, okay? And here is how we do it. First, before we go any further, now understand we're looking at case number 1 right now, okay? We'll look at case number 2 in a little bit later, okay? Right now we're going to use synthetic division for long division. Now, synthetic division, are you listening, can only replace long division when the divisor looks something like this. I would write this down, students. This is so important. You can only use synthetic division in place of long division when the divisor looks something like this. Now when I say something like this, let me explain what I mean, okay? First of all, please take some really good notes on this. First of all, you must have a binomial for your divisor. A binomial, and I do have a binomial. Second of all, your lead coefficient must be 1, and my lead coefficient is 1. Next, my exponent of the variable. Let's just use the word degree. How's that? We know what the word degree means. Your degree, that's a really nice D, isn't it? Your degree must be a 1, or in other words, it must be a linear binomial. Remember, first degree is linear, second degree is quadratic, third degree is cubic, fourth degree is quartic, okay? So, let's review. Your divisor, in other words, if you're doing a long division, your divisor right here outside the box, this, it must be a what? Binomial. Your lead coefficient must be what? 1. The degree must be 1, okay? And here's the last one. Your lead coefficient must be positive. Must be positive. Got it? Lead coefficient must be positive. Now, if those 4 things don't exist, listen, you cannot use synthetic division. You must use what? Long division. Now, when I show you how to use synthetic division, you're going to fall in love with it. It's great. You're going to want to use it all the time. Unfortunately, you can't. You can only use long synthetic division when these 4 things exist with your divisor. Okay? If just one of these is missing, you're going to have to use long division. Third time, binomial must be a binomial. Your lead coefficient must be 1. Your degree must be 1. And the lead coefficient right here must be positive. Now, students, I'm going to probably give you some problems on a test or a quiz in which I say, divide this by using synthetic division. I'm going to give you one that you can't do it. So your answer will have to be, can't be done. Or you could put, I must must use long division of something. But you need to know when you can use synthetic division and when you can't. Got it? You must know this. Okay, moving on. Here are the steps for using synthetic division in place of long division. I'm going to put these up quickly. You can pause the video and copy them down. Make sure the divisor and the dividend are both written in standard form. Number 2, set the problem up in synthetic division form. I will teach you how to do that. Be sure, look, it's all capitalization here. Be sure to put in zeros. And change the sign of the constant term of the divisor. I will go over all of this with you later, trust me. Okay? Number 3, bring down the first number and then multiply and combine it over and over until you've reached the end of the problem. Write your final answer in polynomial form. Now, I'm going to move on and pause the video, copy these down, and then we'll continue on together. Alright? These are the 4 steps for using synthetic division in place of long division. Alright? Okay, here we go. Let's try 3 of these problems. Let's try 3 of these problems. Here's your first one. Now what I'd like you to do is I'd like to sit back and relax and watch me solve this. Go ahead and copy this problem down. Watch me solve it long division, okay? Because I want to show you get the same answer. Alright? Now here's long division. Watch how long this takes. I don't remember all the steps I gave, but I know most of them, okay? Make sure this is written in standard form, and it is. Make sure this is written in standard form, and it is. No, you do not have to take notes on this unless you want to. Just watch, okay? Divide first term into first term. So x goes into 2x cubed, 2x squared times. Next, I told you to take this and multiply it by both of these terms right here, okay? So 2x squared times x, 2x cubed. 2x squared times negative 3, negative 6x squared. There's no x squared for me to put my negative 6x squared underneath, so I'm going to put it off to the end over here, okay? Alright, let's continue on. Next step, I'm going to change these signs and combine. So here we go. These cancel. Bring everything down. 5x, negative 7, positive 6x squared. Now, next step is to make sure all of these terms are written in standard form. So I'm going to write all of these in standard form, okay? There we go. And we'll put that plus sign right here. There we go. Alright. Next step. Divide first term into first term. X goes into 6x squared. Positive 6x. Now take this times these two terms. 6x times x, 6x squared. 6x times negative 3, negative 18x. Change the signs and combine. These cancel. You're left with 23x. Bring down your negative 7. Okay, next, divide first term into first term. X goes into 23x 23 times. 23 times x is 23x. 23 times negative 3 is negative 69. Change your signs and combine. Negative, positive. These cancel. You're left with a positive 62. Now you know you're finished because x will not go into 62. So there's your answer. Now I hope I didn't make a mistake somewhere. Alright? Hopefully I did, but here we go. Now, you're not supposed to know how to do synthetic division. Okay, but just watch how fast I can do synthetic division. Okay, watch this. I'm going to put a positive 3 here. I'm going to put 2, 0, 5, negative 7. Bring this down, multiply, combine, multiply, combine, multiply, combine. And there's my answer. 2, 2, 6, 6, 23, 23, remainder. So your answer is 2x squared plus 6x plus 23 plus 62 over x minus 3. I did that in about 15 seconds, maybe 20 seconds. Okay? Now I know you don't know what I did. I'm going to teach you now how to do that. That is sweet. That is so fast compared to long division. But the bad news is, once again, the bad news is you can only use synthetic division when you have the situation right here. You must have a binomial, lead coefficient of 1, degree of 1, and the first term must be positive. Okay? Alright. Here we go. Let me teach you how to do synthetic division. You're going to like it a lot. Okay? First of all, I look at this and I realize right away I can definitely use synthetic division. I have a power of 1. I have a binomial degree of 1, constant term of 1, and it's positive. So I can definitely use synthetic division. So follow these steps carefully and we'll see if we can do this, okay? Step 1, make sure the divisor and the dividend are written in standard form. Standard form, check. Standard form, check. Set up the problem in synthetic division form. Now you don't know how to do that, so let me teach you. You put a box like this. And then these numbers right here, these coefficients right here, go across the top here. Got it? So your first number's a 2. And you would think your next number would be a 5, right? But that's wrong. You've got to put a 0 in. Because here's why. Well, it says it right here. Be sure to put in zeros. You're missing an x squared. So really it's 2x cubed plus 0x squared plus 5x minus 7. See the condensation? 3. Or see how it goes down? 3, then 2, then 1, then constant term. If you're missing any terms in your dividend, you must put in zeros. Do you see it? You went from a power of 3 to a power of 1. You're missing a term, so you put a 0 in. So the first thing you do when it comes to setting up the problem in synthetic division form, the first thing you do is you put a box like this. Then you put the coefficients right here of your dividend, not this, of your dividend going across the top. So a 2, then a 0, then a 5, then a -7. Mr. Earhart, what if I forget to put a 0 in? Hey, listen, you can run a test. What is your degree right here? 3. In your head, add 1. What is 3 plus 1? 4. How many numbers do you have? 4. If you'll always add 1 to this number in your head, it should match how many numbers you have going across. That's a great side note. I would pause the video and write that down. If you add 1 to this number, whatever your degree is on the dividend, if you add 1 to this number, that will tell you how many numbers you should have going across. Okay? So step 2, set up the problem so that division form. Be sure to put in zeros and change the sign of the constant term. Okay, here's your constant term. Not this constant term. Nope. Constant term of the what? Look, guys. Divisor, not dividend. This is your dividend. This is your divisor. And by the way, this should have division signs right here. I apologize. I don't know what happened to those, but they got left off. Okay, so change the sign of your constant term of the divisor. Here's your divisor. Your constant term is -3. So we're going to put a +3 here. Now you know what? Once you get this down, you're going to love it. It's so fast. Let me go over step 2 again. First of all, we draw a box. Okay? Second of all, you list out all of your coefficients of your dividend right across the top. Make sure you put in zeros if you're missing any terms. In your head, you can add a number to the degree, and that should tell you how many numbers you have. Change the sign of your divisor, the constant term, and put it right here. Step 3, bring down the first number. Well, that's easy. Bring down the first number. Booyah, piece of cake. Next, you multiply and combine over and over until you get to the end of the problem. This is so easy. Watch this. 3 times 2 is 6. That's your multiply. What do? We multiply and then what? Combine. So combine these two numbers and you get what? Combine means like they're like terms. Combine them. 0 plus 6. 6. Now we do what again? Multiply. 3 times 6 is 18. Now what do? Combine. +5, +18, +23. What do next? Multiply. 3 times 23, 69. What do next? Combine. -7, +69, +62. Boom. Now that is so fast. You bring down your first number. Multiply, you got a 6. Combine, you got a 6. Multiply, you got 18. Combine, you get 23. Multiply, you get 69. Combine, you get 62. Last step, write your answer in polynomial form. Oh, this is so easy, guys. Look at the degree of your dividend. It was 3, right? See that? It was 3, correct? Always go 1 less than that. What's 1 less than 3? 2. So here you put an x squared. Next you put an x to the 1. This is your constant term. And you know what this is right here? It's always your remainder. So your final answer looks like this. 2x squared +6x. If you want to put the 1, you can. You don't have to. +23 Then how do we write our remainder? Remember, we put plus 62 over what's your divisor? X minus 3. Booyah. Now that's fast. I'm telling you, this is a great, fast process if you'll learn to do it, okay? We got 2 more of these. Hang with me, follow these steps, and you'll be fine, okay? Alright, here we go. Let's try another one. Alright, step 1. Let's first of all make sure we can use synthetic division. Do I have a binomial? Yes. Is my degree 1? Yes. Is my lead coefficient 1? Yes. Is it a positive lead coefficient? Yes, so we're good. Step 1, make sure the divisor and dividend are both written in standard form. Standard form, we're good. Standard form, we're good. Step 2, set the problem up in synthetic division form. Okay, put your box. Change the sign of this number here. You're dividing by x plus 1. You have a positive 1 right here, so we're going to put a negative 1. Okay? Then list out all of your coefficients. Now notice you're not missing anything. 3, 2, 1. Constant term. Oh, by the way, guys, if there is no constant term here, then you would have to put a what? 0. Okay, you have to do that. Alright, so here we go. My coefficients are 1, positive 2, negative 5, negative 6. Now let's run our test. What is your degree? 3, add 1 to 3 in your head, you get 4, right? 3 plus 1 is 4. You should have 4 numbers. Do you have 4 numbers right here inside the box? Yes, you do. So you're good. Okay, step 3, bring down the first number and then multiply and combine over and over and over. So here we go. Bring down your first number. Multiply. Negative 1 times 1, you get negative 1. Combine positive 2 and negative 1 is 1. Multiply negative 1 times 1, that's negative 1. Combine negative 5, negative 1 is negative 6. Multiply negative 1 times negative 6 is positive 6. Combine negative 6, positive 6 is 0. So in this case, your remainder is 0. So you have no remainder in this problem, okay? Now, what is the degree of your dividend? 3. Go 1 less than that. You always go 1 less than that, which is 2. So I have 1x squared, 1x to the 1, and there's my constant term. So my answer is 1x squared. Positive 1x, or just x, negative 6, no remainder. So if you were to do long division like this, x plus 1 going into x cubed. Now relax, I'm not going to do the long division, okay? I'm not going to waste that time. But if you were to do long division, you would get x squared, positive x, negative 6. Exact same answer. Only this is a million times faster. But it only works on certain problems, don't forget that, okay? Alright, moving on. Our last example, then we'll look at our second situation in which we can use synthetic division. Alright, now, here we go. Step 1. Make sure you can use synthetic division. Do we have a binomial? Yes. Is my lead coefficient 1? Yes. Is my degree 1? Uh-oh. No, it's not. We got a problem. So right now you would stop and you would put cannot use synthetic division. And you'd have to use long division, okay? However, because I want practice, and I did do that on purpose, but now that I've done that, let's pretend that's gone. We'll pretend there's a 1 there, okay? Alright, let's continue on. Now, do I have a binomial? Yes. Do I have a power of 1? Yes. Do I have a coefficient of 1? Yes. Is my lead coefficient positive here? Yes. So we're good. Step 1, make sure the divisor and dividend are standard form. Yep, standard form. Yep, standard form, no problem there. Step 2, set up the synthetic division problem. Okay, no problem. There's my box. This is a positive 5, so I'm going to put a negative 5. And then list out your coefficients. Now you're missing some terms, guys. You have a 3, and then it goes from x to the 4th. You're missing an x to the 3rd, so put a 0. Then your x squared number is negative 5. Then your x to the 1 power is 1. There's a 1 right here. And then there's no constant term on the end. There's no constant term on the end. So put a 0 right here for your constant term. There's no constant term on the end. Okay, there's got to be a constant term, so put plus 0. Now, let's run our test. What is your degree? 4 in your head. Add 1 to that and you get 5, right? You should have 5 numbers inside the box. And we do, so we're probably pretty good, okay? Alright, here we go. Do your multiplying and combining over and over and over. So bring down your first number. Negative 5 times 3, negative 15. Combine negative 15. Negative 5 times negative 15, positive 75. I did that in my head as 825. Yeah, that's right. Combine and you get positive 70. Negative 5 times 70, negative 350. Combine and you get negative 349. Negative times a negative is positive. 349 times 5 would be what? 45. Carry your 4, 24. Carry your 2. I think it's 1,745. But let me grab a calculator and just make sure real quick, okay? 349 times 5 is 1,745, okay? Negative times a negative is positive. Combine and you get this right here. No problem. Are you ready? What is the degree? Excuse me. What is the degree of your dividend? 4, right? So we're going to start with a 3 and x to the third power. Go 1. Go 1 less than this. So I'm going to put an x to the third here. This is my x squared term. This is my x term. This is my constant term. This is my remainder. So my answer is 3x cubed, negative 15x squared, positive 70x, negative 349, plus 1,745 over your divisor, x plus 5. So Mr. Arrow, you're telling me if I took x plus 5 and divided it into this right here, I would get this right here. Yes, you would. I wish I had time to do that. I'm not going to, but you would. Okay. Alright. So that's one scenario in which we can use synthetic division, okay? But remember, there has to be a certain scenario in which synthetic division can replace long division. Okay, moving on. Now, remember, I mentioned this earlier in the video, synthetic division can also be used to evaluate a function at a given value. Now, this method can be very helpful. Let me show you what I mean by evaluate a function at a given value. Do not, well, you can write this down if you want to, but you don't need to. I just want you to listen. If I ask you to evaluate that function at f of 2, that means everywhere there's an x, I would put a 2. Now watch how long this takes. Okay, do your powers first. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 2 to the third power is 8. 8 times negative 3 is negative 24. 2 times 2 is positive 4. 6 times 2 is a negative 12. Positive 10. Add up all of your positives. 32 plus 4 is 36. Plus 10 is 46. Now add up all of your negatives. You get a negative 36. So your answer would be 10. Got it? Now watch how fast synthetic division is, okay? Watch this and be amazed. I'm just kidding, but watch this, okay? If I can actually get this thing out of the way. Well, we'll do it right here. Now watch how fast synthetic division works. Put your box. You're evaluating it at 2. Put a 2 here. 2, negative 3, 1, negative 6, 10. Bring down your 2. Multiply. Combine. Multiply. Combine. Multiply. Combine. Multiply. Combine. What did we get out over here? 10. What's your last number right here? 10. Booyah. It works perfectly, and that's so much faster than doing all of this. Okay? Now there's really, remember in long division or in synthetic division, you could only use it when the divisor was, had a binomial, power of 1, the coefficient of 1 had to be positive, all that stuff. Well, there's really no stipulation when you're evaluating a function at a given value. You can use synthetic division whenever you want when you're evaluating a function at a given value, okay? That's the good news, okay? So this last number here will be your answer. So let me teach you how to do this, alright? Here are the steps. Please copy these down and pause the video if you need to. The first zeros were needed. Stop. 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 Listen. Did you see the difference? When you're using synthetic division for long division, you had to do what? Change the sign of the constant term. Remember that? Positive 5 here. What did I put? Remember that? Notice you do not do that when you're evaluating the function at a given value. Okay? You do not change any signs. Alright? Do not. Back here, I was evaluating the function at what number? Remember, I was putting 2 in for x, right? And what number did I put here? Did I change the sign? I put a -2 here. No, I did not. I just put a 2. No, I can explain why. I know why. I'm not going to get into that now, okay? But make sure you understand that. And then look, same thing, bring down the first number and multiply and combine over and over until you reach into the problem. The last number at the bottom right is your answer. It's that easy, guys. Now, I'm going to move on, pause the video, copy these steps down, and then move on when you're ready. We're going to do 3 of these, okay? I would like you to evaluate this function at -4. That really it should say f of x equals. That's really bad on my part. Sorry, guys. It should say f of x equals. Okay? We're going to evaluate it at f of -4. Got it? So, let me see something real quick back here. Okay. Now, here we go. Okay? We're going to set it up in typical synthetic division form. So, I put a box. Do not change the sign of this number. And I didn't say this, but it goes without saying. This should be written in standard form. I have a 3, then a 2, then a 1, then a constant term, so we're good. I have a coefficient of 1, coefficient of 8, coefficient of 8, and a coefficient of -32. Hey, let's run our test. What is your degree? 3, add 1 to that in your head, you get a 4. There should be 4 numbers inside the box. And there are, so we're good. Okay, bring down your first number. Multiply, you get a -4. Combine these two numbers, positive 8, -4, you get 4. -4 times 4, -16. Positive 8, -16, combine those, you get a -8. Multiply these two, you get a positive 32. Combine those, you get a 0. Look at that. So when you go through, when you substitute -4 in for x, everywhere there's an x, when you substitute -4 in everywhere there's an x and simplify all this, you'll get a 0. So in other words, are you listening? In other words, there's an ordered pair that satisfies this function. -4, comma, 0. You put in -4, that's your x value. You got out 0, your y value. That's a y, not a 4, your y value. Okay? This is going to be really helpful later. Later on, we're going to use synthetic division when we start finding zeros of functions. Okay? And so you must know how to do this quickly. So this is an ordered pair. I put is your input. This is your output. I put in a -4 for x. I got out a 0 for y. This is so much faster than doing all of this right here. Alright, let's continue on. Let's take a look at another example. Now, I really messed up by not putting f of x. So when you write this in your notes, would you please listen to me? You should write this. You should write evaluate f of x equals, and then put this right here at f of -1. You really should, guys. That's the right way to put it, okay? Alright, so here we go. Now you could, everywhere there's an x, put a -1. You could do that. But I want us to practice synthetic division. I might even go ahead and do this real quick, just to show you got the same answer, okay? -1 to the power is -1 times 2 is -2. -1 -1 to the third power is -1 times 3 is times -3 is a positive 3. Positive times a negative is -1. Do we get out 0 again? That's really a coincidence. You don't usually, that doesn't always happen. -2, -1 is -3. Plus 3 gives you out a 0. Now, hopefully you didn't take notes on that. I just want you to take notes on the synthetic division part, okay? So here we go. Let's evaluate this function at -1. But instead of doing it this way, by the way, this is called direct substitution, if you want to know what it's called. this method right here that you're used to doing where you put a -1 in for x. Everywhere there's an x, you put a -1. That's called direct substitution. Okay? And that's what we got out. Now let's use synthetic division. Okay, I'm evaluating the function at -1, f of -1, put a -1 here. You have a fifth degree, so I'm going to put a 2. Notice there's no fourth, x to the fourth power, so I put a 0. For my x cubed, I put a -3. Notice there's no x squared term, so I put a 0. The coefficient of my x is 1. Hey, and look, there's no constant term, you gotta put a 0. There's no constant term, be sure and put a 0 at the end. Now, let's run our test. What degree is this? 5. Fifth. In your head, add 1, you get a 6. There should be 6 numbers inside your box. And there are, so we're good. Okay, let's go fast. Bring down your number. And -1 times 2, -2. Combine these two numbers, you get a -2. -1 times -2, +2. A -3 and a +2. Combine those, you owe me $3, you pay off 2. You're left with a -1. -1 times -1, +1. 0 plus 1 is 1. -1 times 1 is -1. Combine those, +1 and -1, you get a 0. -1 times 0 is 0. 0 plus 0 is 0. What's your last number right here? 0. What's it supposed to be? 0. So that means in this function right here, when you put in -1, you get out what? 0. Okay, got it? One more problem, okay? This is called using synthetic division to evaluate a function at a given value. You've always used direct substitution in the past. Now you're learning a different way to do that, okay? And I'm sorry for all the typos. That should be a little 3, x cubed. That should be a little 2, x squared, okay? Alright, here we go. Now remember in your notes, I would appreciate if you would put evaluate f of x equals, and then put this at f of 2. That means everywhere there's an x, we're going to put in 2. If we were using the direct substitution method, which you're used to, but we're not going to, we're going to use synthetic division. Step 1, set the problem up in synthetic division form. So here we go, there's my box. I'm evaluating the function at 2. Do not change the sign. Okay, here we go. X cubed, my coefficient is 1. X squared, my coefficient is -3. X, my coefficient is 1. My constant term is -3. Now, what is my degree? 3. In your head, add 1 to that and you get 4. I should have 4 numbers inside my box, and I do. Okay, here we go. Bring down your first number. 1. 2 times 1 is 2. -3 times, not times, sorry. -3 and a +2 gives you a -1. Multiply 2 times -1, you get a -2. Combine a +1 and -2 is a -1. 2 times -1 is -2. Combine, you owe me 3, you owe me 2, now you owe me 5. So if you were to go through and everywhere there's an x, if you put a 2, like this, and work this entire problem out, what would you get? You would get -5. So what that means is this, students, you have an input of 2. You put in a 2 and you got out a -5. This ordered pair exists or satisfies this polynomial function right here. 2 comma -5. Guys, I hope you're grasping this. Understand there are 2 situations in which we're going to use synthetic division. Number 1, in place of long division, as long as your divisor meets the 4 stipulations that I taught you. And then we're going to use synthetic division for in place of direct substitution or evaluating a function at a given value. Okay? I hope this video has been helpful. If you have any questions, don't hesitate to call or email.